The subject of my project is predicting the daylines of the Helsinki area. First of all, the background of this topic is because the length of the day will affect many things. For example, the daylines will affect the flowering and fruiting of crops. Second, the length of the day can affect people's mood. Many data shows that night is easy to make people feel depressed, especially for winter in Finland. The long and the cold nights will affect people's social interaction. And finally, the daylights also affect the supply of infrastructure in cities, such as the cost of electricity consumed by streetlights. And next, about the data side, I got the data from time and date website, which can cure the detailed data of the specific city, including the sunrise time, sunset time, and so on. And in this project, we mainly select the first part of the data because this is more intuitive for people to feel the length of the day. I will analyze two situations here using different features respectively. And first, considering the daylines changes with seasons, I will predict the daylines based on the date. And the second is to predict the daylines based on the sunrise time, because the daylines is directly related to the sunrise time. And normally, the earlier the sunrise, the longer the day will be. And the label is the daylines here, the right column. To analyze the data, I have done a certain data transformed here. First is the date. For example, I will transfer the 4th of February into an integer 35, and the sunrise time is converted to a float number, such as if the sunrise is 10 past 8, then I will use 8.1. And for the data lines, it will be converted to an integer, which will represent the duration in seconds. And for the training site and the validation site, I will use a 2021 for year data obtained from the website. And for the test data, I will use a whole year data of 2020 and the data as of March 9th in 2022. So first, about the data side, I made a simple analysis of the obtained data. From the figure, we can easily find that the distribution of data points according to the sunrise time is closer to the linear model, and the distribution of data points by date is closer to a polynomial model. So I will use linear regression for the first one and use polynomial regression at the different levels to fit the data for the second one, and then to find the best order. And since there is no obvious outliers in the data in either case, I would choose MSE as a loss function. For the first case after simulation with Python, it can be seen that there is a certain gap between the predicted data and the real data. But the difference is like within 30 minutes, which is considered to be within the acceptable range. And at the same time, through the test data, it is found that the test error of whole year of 2020 is greater than the test data of 2022. So it can be considered that the accuracy of the model matching the data in the first half of the year is higher than that of the whole year. And for the second case, it can be seen that the training error and the validation error are lowest at order 5. And through the test data, you can see that the model fits the test data almost perfectly, especially for the data of 2022. However, there are still some deviations for the data in middle of 2020. And from the above two methods, we can see that the daylines data can be accurately obtained for most of the time through the date value. So we will choose the second case and choose 5 as the perfect order for this polynomial regression. And I also realized that this solution can also be optimized. For example, for the prediction based on the date with polynomial regression, although we choose the order 5 as the optimal solution, the model can be further simplified by regularization. And secondly, through the sunrise time prediction, it can be seen that there is a certain gap in the daylines obtained by a similar sunrise time. I guess this may be related to the seasons. For example, the daylines of the sunrise at 7 o'clock in the spring may be longer than the daylines of sunrise at 7 o'clock in the autumn. Therefore, if I consider both the date and the sunrise time as featured in one model, this may improve the accuracy of the prediction. And that's all. Thank you.